What if the next great chapter of human history isn't written on Earth, but among the stars? Picture this, a future where humanity isn't bound by the limits of our planet, where the vastness of space becomes our playground, and the stars are no longer distant lights, but destinations. This isn't science fiction, it's a vision of what could be, and it's closer than you might think. Today, we're diving into 30 visionary predictions that could redefine galactic-scale exploration, reshaping not just how we travel, but how we live, think, and dream. From interstellar travel becoming as routine as a morning commute to the discovery of alien life that challenges everything we know about existence, these ideas aren't just possibilities, they're glimpses into a future that's waiting to be built. So if you've ever looked up at the night sky and wondered what's out there, stay with us. By the end of this journey, you'll see the universe in a whole new light, and maybe even imagine your place in it. Let's begin. Now, let's take a closer look at our first prediction, interstellar travel becoming as routine as air travel. Imagine stepping onto a spacecraft not for a rare, once-in-a-lifetime journey, but for a quick trip to another star system. This future hinges on breakthroughs in propulsion technology, like warp drives or light sails, which could revolutionize how we move through the cosmos. Warp drives, for instance, might allow us to bend space-time, effectively shortening the distance between stars. Light sails, on the other hand, could harness the power of sunlight or lasers to propel spacecraft at incredible speeds without the need for heavy fuel. These technologies could turn what once seemed like a distant dream into an everyday reality. But what would this mean for society? For starters, interstellar travel could open up entirely new economic opportunities. Imagine industries built around mining asteroids in distant star systems or tourism companies offering luxury vacations on alien worlds. The demand for skilled workers in space engineering, navigation, and even hospitality could skyrocket, creating jobs we can't even imagine today. At the same time, the cost of space travel would likely drop as technology becomes more efficient and accessible, making it possible for more people to explore the stars. Economically, the ripple effects could be enormous. Just as air travel transformed global trade and connected distant cultures, interstellar travel could link entire star systems, fostering trade and cultural exchange on a galactic scale. New markets for resources, technology, and even art could emerge, reshaping economies both on Earth and beyond. However, this shift wouldn't come without challenges. Governments and corporations would need to navigate complex questions about ownership, regulation, and the equitable distribution of resources across star systems. As we stand on the brink of this new era, one thing is clear: interstellar travel could redefine what it means to be human. It's not just about reaching new worlds, it's about expanding our horizons, both literally and figuratively. And with that thought, let's move on to the next prediction, where we'll explore the challenges that come with venturing into the unknown. Now, as we venture deeper into the realm of interstellar travel, it's important to acknowledge the challenges that come with such an ambitious endeavor. While the idea of hopping between star systems sounds thrilling, the reality is far more complex. One of the most significant hurdles is time dilation, a phenomenon predicted by Einstein's theory of relativity. As spacecraft approach the speed of light, time slows down for those on board compared to people on Earth. This means that while a journey might feel like a few years for the travelers, decades or even centuries could pass back home. Imagine returning to a world where everyone you knew has aged or is no longer there. This raises profound questions about how we perceive time and the social implications of such journeys. Another major challenge is radiation exposure. Beyond Earth's protective magnetic field, space is filled with cosmic rays and solar radiation that can pose serious health risks to astronauts. Prolonged exposure could lead to increased risks of cancer, damage to the nervous system, and other long-term health issues. Shielding spacecraft from this radiation is no small feat, and current technologies are still far from providing a foolproof solution. Researchers are exploring innovative materials and magnetic fields to create safer environments, but this remains a critical obstacle to overcome. Then there's the psychological toll of long-term space travel. Spending months or even years in the confined, isolated environment of a spacecraft can take a heavy mental and emotional toll on astronauts. The lack of natural light, the monotony of daily routines, and the absence of familiar social interactions can lead to feelings of loneliness, depression, and even cognitive decline. Maintaining mental health in such conditions will require not only advanced psychological support systems, but also creative solutions to keep travelers engaged and connected to their mission and loved ones. These challenges remind us that interstellar travel isn't just about technological breakthroughs, it's also about understanding and addressing the human element. As we push the boundaries of what's possible, we must also prepare for the physical, emotional, and social complexities that come with venturing into the unknown. With these hurdles in mind, let's turn our attention to the next prediction, where we'll explore how humanity might establish self-sustaining colonies beyond our solar system. Now, shifting our gaze to the stars, let's explore the fascinating possibility of self-sustaining space colonies. Imagine a future where humanity isn't just visiting distant planets or moons, but thriving on them, creating entirely new societies far from Earth. This vision hinges on two groundbreaking technologies: closed-loop life support systems and in-situ resource utilization. Together, these innovations could allow us to build colonies that are not only self-sufficient but also capable of growing and evolving over time. Closed-loop life support systems are the backbone of any sustainable space colony. These systems are designed to recycle and reuse essential resources like water, air, and nutrients, mimicking the natural cycles we rely on here on Earth. For example, water used for drinking, cleaning, or growing plants would be purified and reused, while carbon dioxide exhaled by colonists would be converted back into breathable oxygen through advanced filtration and chemical processes. This closed-loop approach minimizes waste and ensures that colonies can operate independently for extended periods, reducing the need for constant resupply missions from Earth. But what about food, building materials, and energy? This is where in-situ resource utilization comes into play. Instead of transporting everything we need from Earth, future colonies could harness the resources available on their new home worlds. For instance, on the Moon or Mars, colonists could extract water from ice deposits, mine metals and minerals from the soil, and even use local materials to 3D print tools, habitats, and infrastructure. By leveraging the resources of their environment, these colonies could become truly self-reliant, paving the way for long-term habitation and expansion. Of course, establishing self-sustaining colonies isn't just about technology, it's also about adaptability and innovation. Colonists would need to develop new ways of living and working in environments vastly different from Earth. From designing energy-efficient habitats to cultivating crops in low-gravity conditions, every aspect of life would require creative solutions and a willingness to experiment. Over time, these colonies could evolve into thriving communities, each with its own unique culture and identity, shaped by the challenges and opportunities of their new worlds. As we look ahead, the idea of self-sustaining space colonies offers a glimpse into a future where humanity's reach extends far beyond our home planet. It's a vision that combines cutting-edge technology with the resilience and ingenuity of the human spirit. And with that in mind, let's turn our attention to the next frontier, the concept of terraforming and how we might transform barren worlds into Earth-like havens. Now, let's take a closer look at one of the most ambitious ideas in galactic exploration, terraforming. Imagine turning a barren, lifeless planet into a thriving, Earth-like haven, complete with breathable air, flowing water, and lush ecosystems. This concept, while still in the realm of science fiction, holds the potential to redefine humanity's place in the universe. But how exactly could we achieve such a monumental transformation, and what challenges, both technical and ethical, would we face along the way? Terraforming begins with the idea of altering a planet's environment to make it habitable for humans and other Earth-based life forms. Take Mars, for example. To transform the red planet, we'd need to address its thin atmosphere, freezing temperatures, and lack of liquid water. One proposed method involves releasing greenhouse gases into the Martian atmosphere to trap heat and gradually warm the planet. Over time, this could melt the polar ice caps, releasing water vapor and carbon dioxide, which would further thicken the atmosphere and create a more stable climate. With enough time and effort, Mars could potentially support plant life, which would then produce oxygen, paving the way for a breathable atmosphere. But terraforming isn't just about warming up a planet, it's about creating a balanced, self-sustaining ecosystem. This would require introducing microorganisms, plants, and eventually animals to establish a functioning biosphere. Think of it as building a new Earth from the ground up, where every element, from soil composition to atmospheric pressure, must be carefully calibrated to support life. It's a process that could take centuries, if not millennia, but the rewards could be extraordinary. Entire worlds transformed into homes for future generations. Of course, the idea of terraforming raises significant ethical questions. Should we alter an entire planet's environment, even if it means erasing its natural state? What if there's microbial life already present on these worlds? Do we have the right to disrupt or destroy it in our quest for expansion? These are complex dilemmas that challenge our understanding of responsibility and stewardship in the cosmos. Some argue that terraforming is a natural extension of humanity's drive to explore and thrive, while others caution against the potential consequences of playing planetary engineer. Beyond the ethical concerns, there are also practical challenges to consider. The sheer scale of terraforming would require unprecedented levels of resources, technology, and international cooperation. It's not just a scientific endeavor, it's a societal one, demanding global collaboration and long-term commitment. And even if we succeed, we'd need to ensure that these new worlds remain stable and habitable over the long term, avoiding the pitfalls of environmental degradation that we faced here on Earth. As we ponder the possibilities of terraforming, it's clear that this concept represents both a bold vision for the future and a profound responsibility. It challenges us to think beyond our current limitations and consider what it truly means to become a multi-planetary species. With that in mind, let's turn our attention to another groundbreaking frontier: the role of artificial intelligence in revolutionizing galactic exploration. Now, shifting our gaze to the stars, let's delve into how artificial intelligence could become the backbone of galactic exploration. Imagine a future where spacecraft navigate the cosmos autonomously, making split-second decisions without human intervention. Artificial intelligence has the potential to transform how we explore the universe, acting as both a guide and a partner in our quest to uncover its mysteries. One of the most exciting applications of artificial intelligence in space exploration is the development of autonomous spacecraft. These intelligent machines could travel vast distances, analyze alien environments, and even repair themselves without needing constant input from Earth. For example, an AI-powered probe could land on a distant moon, assess its surface for signs of life, and decide the next steps of its mission, all in real time. This level of autonomy would allow us to explore regions of space that are currently beyond our reach, opening up new frontiers for discovery. But artificial intelligence's role doesn't stop at navigation. It could also revolutionize how we conduct research in space. Imagine AI systems capable of sifting through massive amounts of data collected by telescopes and satellites, identifying patterns or anomalies that human scientists might miss. These systems could help us detect exoplanets, analyze atmospheric compositions, or even predict cosmic events like supernova. By accelerating the pace of discovery, artificial intelligence could unlock answers to some of the universe's most profound questions. Another groundbreaking possibility is AI-driven decision-making in uncharted territories. When exploring distant planets or moons, human missions face significant delays in communication due to the vast distances involved. Artificial intelligence could bridge this gap by making critical decisions on the spot, ensuring the safety and success of missions. For instance, if a rover encounters unexpected terrain or a spacecraft faces a technical issue, AI could assess the situation and implement solutions without waiting for instructions from Earth. This capability would not only save time but also reduce risks, making space exploration more efficient and reliable. However, the integration of artificial intelligence into galactic exploration also raises important questions. How much autonomy should we grant these systems? What happens if an AI makes a decision that conflicts with human priorities? These challenges highlight the need for careful design and oversight to ensure that artificial intelligence serves as a tool for progress, not a source of conflict. As we look to the stars, it's clear that artificial intelligence could be the key to unlocking the next chapter of galactic exploration. From autonomous spacecraft to data-driven discoveries, AI has the potential to reshape how we understand and interact with the universe. With that in mind, let's turn our attention to the ethical implications of using artificial intelligence in space, and how we can ensure it aligns with our values as we venture into the unknown. As we venture deeper into the role of artificial intelligence in galactic exploration, it's crucial to pause and consider the ethical dimensions of this powerful technology. While AI offers incredible potential, it also brings with it a host of complex questions that demand careful thought and responsible action. One of the most pressing concerns is the level of autonomy we grant to these systems. Should an AI-powered spacecraft have the authority to make life or death decisions without human oversight? This question becomes even more critical when missions involve the search for extraterrestrial life or the colonization of distant worlds. Striking the right balance between autonomy and control is essential to ensure that AI serves humanity's best interests rather than creating unintended consequences. Another ethical challenge lies in the decision-making processes of artificial intelligence. Unlike humans, AI systems operate based on algorithms and data, which means their decisions are driven by logic rather than emotion or moral reasoning. While this can be an advantage in many scenarios, it also raises concerns about how these systems might handle situations where ethical dilemmas arise. For example, if an AI-controlled rover discovers a fragile alien ecosystem, how should it prioritize scientific exploration versus environmental preservation? These decisions could have far-reaching implications, not just for the mission but for our understanding of the universe and our place within it. Conflicts between human and machine priorities also present a significant ethical hurdle. As AI systems become more advanced, there's a risk that their objectives might diverge from those of their human creators. This could lead to scenarios where AI makes choices that are technically optimal but ethically questionable. For instance, an AI might prioritize mission efficiency over the safety of astronauts or the preservation of alien environments. To prevent such conflicts, it's vital to establish clear guidelines and ethical frameworks that govern the behavior of AI in space. These frameworks should be designed to align AI decision-making with human values, ensuring that our exploration of the cosmos reflects our commitment to responsibility and respect. Transparency and accountability are also key considerations. As we rely more on AI for critical tasks, it's essential that these systems operate in ways that are understandable and auditable. If an AI makes a controversial decision, we need to be able to trace the reasoning behind it and hold the appropriate parties accountable. This requires not only advanced technical solutions, but also a commitment to ethical oversight and public engagement. By involving diverse perspectives in the development and deployment of AI, we can create systems that are not only effective but also aligned with the broader goals of humanity. Ultimately, the ethical use of artificial intelligence in space exploration is about more than just technology. It's about defining who we are as a species and how we choose to interact with the universe. As we push the boundaries of what's possible, we must also ensure that our advancements reflect our highest ideals. With that in mind, let's turn our attention to another groundbreaking possibility: the harnessing of energy from space and how it could transform life on Earth and beyond. Now, let's shift our gaze to a future where the stars themselves could power our civilization. Imagine a world where energy is no longer a scarce resource, but an abundant, limitless force harnessed directly from space. This is the promise of space-based energy harvesting, a concept that could revolutionize how we power our planet and beyond. One of the most exciting possibilities lies in solar power satellites. These massive structures orbiting Earth would capture sunlight unfiltered by our atmosphere and beam the energy back to the surface using microwaves or lasers. Unlike ground-based solar panels, which are limited by weather and daylight hours, these satellites could provide a constant, uninterrupted flow of clean energy, transforming the way we think about sustainability. But the potential doesn't stop there. Another groundbreaking idea involves mining helium-3 from the Moon. Helium-3 is a rare isotope that could fuel next-generation fusion reactors, offering a virtually limitless and pollution-free energy source. While helium-3 is scarce on Earth, the Moon's surface is believed to hold vast reserves deposited over billions of years by solar winds. Mining and transporting this resource back to Earth could unlock a new era of energy production, one that could power everything from cities to interstellar spacecraft. The implications are staggering, not just for solving Earth's energy crisis, but for enabling humanity's expansion into the cosmos. Of course, the challenges are as immense as the opportunities. Building solar power satellites would require unprecedented advancements in space construction and energy transmission technologies. Mining helium-3 on the Moon would demand sophisticated robotics, lunar infrastructure, and safe transportation methods. Yet the rewards could far outweigh the hurdles. By tapping into the energy of space, we could not only secure a sustainable future for Earth, but also lay the foundation for a thriving galactic civilization. As we explore these possibilities, we're reminded once again that the universe holds the keys to our survival and progress, if only we're bold enough to reach for them. Now, let's take a closer look at the economic landscape of space-based energy. The potential to harness energy from space isn't just a scientific breakthrough, it's a game-changer for global economies. Imagine a world where energy is no longer tied to finite resources like coal, oil, or natural gas. Instead, we could tap into the virtually limitless power of the sun and other celestial resources, fundamentally reshaping how we produce and consume energy. This shift could solve Earth's energy crisis, providing clean, abundant power to every corner of the globe. But with such transformative potential comes a host of economic and geopolitical challenges that we must carefully navigate. One of the most immediate benefits of space-based energy is its ability to reduce our reliance on fossil fuels. By transitioning to solar power satellites or helium-3 fusion, we could drastically cut greenhouse gas emissions, mitigating the effects of climate change. This would not only save trillions of dollars in environmental damage, but also create new industries and job opportunities in space construction, energy transmission, and resource mining. The economic ripple effects could be enormous, sparking innovation and growth across multiple sectors. However, the road to a space-powered economy is far from simple. The initial costs of developing and deploying these technologies are astronomical. Building solar power satellites, for instance, would require massive investments in space infrastructure, advanced robotics, and energy transmission systems. Similarly, mining helium-3 on the Moon would demand significant funding for lunar bases, transportation fleets, and processing facilities. While the long-term benefits could outweigh these costs, securing the necessary funding and political will remains a major hurdle. Geopolitical tensions could also arise as nations compete for control over space-based energy resources. The Moon, for example, is often referred to as the eighth continent due to its vast reserves of helium-3. If one nation or corporation were to dominate lunar mining operations, it could create a new form of energy inequality, leaving other countries dependent on their supply. To prevent such scenarios, international cooperation and clear regulatory frameworks will be essential. Establishing treaties and agreements that ensure fair access to space resources could help maintain global stability and prevent conflicts. Another challenge lies in the distribution of space-based energy. While solar power satellites could provide clean energy to the entire planet, the infrastructure needed to transmit that energy, such as ground-based receiving stations, would require significant investment and coordination. Developing nations, in particular, might struggle to afford these systems, potentially widening the energy gap between rich and poor countries. Addressing this issue will require innovative financing models and partnerships to ensure that the benefits of space energy are shared equitably. Despite these challenges, the economic potential of space-based energy is too great to ignore. By solving Earth's energy crisis, we could unlock unprecedented opportunities for growth, innovation, and sustainability. Moreover, the technologies developed for space energy could have far-reaching applications, from powering interstellar spacecraft to enabling the colonization of other planets. As we venture into this new frontier, we must approach it with both ambition and caution, ensuring that the economic benefits are realized while minimizing the risks. With the promise of space energy on the horizon, we're reminded that the future of our planet and our species may very well depend on our ability to harness the power of the cosmos. But as we explore these possibilities, we must also consider the ethical and societal implications of our actions. How do we ensure that space energy benefits everyone, not just a privileged few? And how do we navigate the complex web of economic and geopolitical challenges that come with it? These are the questions we must answer as we take the next steps toward a brighter, more sustainable future. Now, shifting our gaze to the stars, let's explore the next frontier in galactic-scale exploration, the concept of a galactic internet. Imagine a future where communication across the vast expanse of space is as seamless as sending a text message on Earth. This isn't just about staying connected, it's about creating a network that binds humanity together, no matter how far we venture into the cosmos. The development of a galactic-scale communication system could revolutionize how we share knowledge, coordinate missions, and even interact with potential extraterrestrial civilizations. At the heart of this vision lies the challenge of overcoming the immense distances between stars. Traditional methods of communication, like radio waves, are limited by the speed of light, meaning messages could take years or even centuries to reach their destination. But what if we could bypass these limitations, enter quantum entanglement, a phenomenon where particles become interconnected, allowing information to be shared instantaneously, regardless of distance? While still in its experimental stages, quantum communication holds the promise of enabling real-time conversations across the galaxy, transforming how we explore and inhabit space. Beyond quantum entanglement, other futuristic technologies could play a role in building this galactic internet. For instance, advanced laser communication systems could transmit data at unprecedented speeds, while networks of relay stations positioned throughout the galaxy could act as cosmic routers, ensuring signals reach their destinations without delay. These innovations would not only support interstellar travel, but also foster collaboration between colonies, research outposts, and Earth, creating a unified web of knowledge and resources. However, the road to a galactic internet is fraught with challenges. Building and maintaining such a vast network would require monumental advancements in technology, infrastructure, and energy. Each relay station would need to be self-sustaining, capable of operating for centuries without human intervention. Additionally, the sheer scale of the galaxy means that even with advanced technologies, coordinating the placement and maintenance of these stations would be a logistical nightmare. Yet the potential rewards unprecedented connectivity and the ability to share discoveries in real time make this a challenge worth pursuing. Another consideration is the ethical and societal impact of a galactic internet. How do we ensure that this network remains secure and free from misuse? In a galaxy teeming with diverse cultures and potential alien civilizations, establishing universal protocols for communication and data sharing will be crucial. We must also address the risk of creating a digital divide on a galactic scale, ensuring that all colonies and species have equal access to this revolutionary tool. As we look to the stars, the idea of a galactic internet reminds us that exploration is not just about reaching new worlds, it's about staying connected to each other. By bridging the vast distances of space, we can create a future where humanity thrives as a unified, interstellar species. But as we take these next steps, we must also consider the challenges and responsibilities that come with such a monumental achievement. How do we build a network that serves everyone, and how do we ensure it remains a force for good in the galaxy? These are the questions we must answer as we embark on this exciting journey. Now, let's take a closer look at the hurdles we'd face in making a galactic internet a reality. One of the most significant challenges is the sheer scale of space itself. Even with advanced technologies, the distances between stars are so vast that communication delays are inevitable. For example, a message sent from Earth to a colony on Proxima Centauri, the closest star system to us, would take over 4 years to arrive and another 4 years for a response. This kind of delay makes real-time communication impossible with current methods, posing a major obstacle for coordination and collaboration across the galaxy. Another critical issue is the need for relay stations. To create a functional galactic internet, we'd need a network of these stations strategically placed throughout the galaxy. Each station would act as a kind of cosmic router, receiving signals and forwarding them to their destinations. However, building and maintaining these stations would be a monumental task. They'd need to be self-sustaining, capable of operating for centuries without human intervention, and resilient enough to withstand the harsh conditions of space, from radiation to micrometeoroid impacts. The logistics of constructing and powering these stations across such vast distances would require breakthroughs in robotics, energy storage, and materials science. Energy is another major concern. Transmitting signals across interstellar distances demands enormous amounts of power. Even with highly efficient laser communication systems, the energy requirements would be staggering. We'd need to develop new ways to generate and store energy on a scale far beyond what we currently use on Earth. Solar power might work for stations near stars, but for those in the void between star systems, alternative energy sources like nuclear or even antimatter reactors would be necessary. Then there's the issue of signal degradation. Over such vast distances, even the most advanced communication methods would face interference from cosmic radiation, gravitational fields, and other space phenomena. Ensuring that signals remain clear and intact over light years of travel would require sophisticated error correction technologies and redundant transmission systems. Without these, critical data could be lost or corrupted, jeopardizing missions and potentially endangering lives. Finally, we must consider the human factor. Coordinating the construction and maintenance of a galactic internet would require unprecedented levels of international and interplanetary cooperation. Different colonies and civilizations might have competing priorities, making it difficult to agree on standards, protocols, and resource allocation. Establishing a unified framework for this network would be as much a political and diplomatic challenge as a technical one. Despite these challenges, the potential benefits of a galactic internet are too great to ignore. By addressing these obstacles, we can pave the way for a future where humanity remains connected, no matter how far we venture into the cosmos. As we continue to push the boundaries of exploration, solving these communication challenges will be key to ensuring that we thrive as an interstellar species. Now, let's shift our gaze to a future where the stars aren't just for exploration, they're for vacation. Picture this: luxury space cruises gliding through the cosmos, offering breathtaking views of distant nebulae and alien sunsets. Galactic tourism could become the ultimate adventure where travelers journey to exotic worlds, walk on alien soil, and experience the wonders of the universe firsthand. This isn't just science fiction. It's a vision of what could be as advancements in space travel and hospitality converge to create an entirely new industry. Imagine boarding a state-of-the-art spacecraft designed for comfort and luxury, complete with panoramic observation decks, zero-gravity lounges, and gourmet dining experiences crafted from ingredients grown in space. These cruises could take passengers to destinations like the icy geysers of Europa, the towering cliffs of Miranda, or even the vibrant, otherworldly landscapes of exoplanets light years away. Each journey would be a once-in-a-lifetime experience, blending the thrill of exploration with the comforts of high-end travel. But galactic tourism wouldn't just be about leisure. It could also play a crucial role in fostering a deeper connection between humanity and the cosmos. By making space accessible to more people, we could inspire a new generation of explorers, scientists, and dreamers. Imagine the impact of seeing Earth from orbit or witnessing the vastness of the Milky Way firsthand. These experiences could reshape our perspective, reminding us of our place in the universe and the importance of protecting our home planet. Of course, this vision isn't without its challenges. The logistics of transporting tourists safely across vast distances, ensuring their comfort in zero-gravity environments, and protecting them from the hazards of space travel would require significant innovation. We'd need spacecraft capable of shielding passengers from cosmic radiation, providing artificial gravity and sustaining life for extended periods. Additionally, the infrastructure to support these journeys, spaceports, refueling stations, and emergency response systems would need to be developed on an unprecedented scale. Then there's the question of accessibility. In its early stages, galactic tourism would likely be a luxury reserved for the wealthy, much like the first commercial flights on Earth. But as technology advances and costs decrease, we could see a democratization of space travel, making it possible for more people to experience the wonders of the cosmos. This shift would not only open up new economic opportunities, but also help bridge the gap between Earth and the stars, fostering a sense of unity and shared purpose among humanity. As we dream of this future, it's worth considering the cultural and ethical implications of galactic tourism. How do we ensure that our presence on alien worlds respects their environments and ecosystems? What protocols should be in place to protect these destinations from over-tourism or exploitation? These are questions we'll need to address as we move closer to making this vision a reality. Galactic tourism represents more than just a new industry. It's a testament to humanity's boundless curiosity and desire to explore. By turning the cosmos into a destination, we're not just expanding our horizons, we're redefining what it means to be a spacefaring civilization. And as we look to the stars, we're reminded that the universe isn't just a place to visit, it's a place to call home. Now, as we venture further into the possibilities of galactic tourism, it's essential to pause and consider the ethical dimensions of this futuristic industry. While the idea of exploring alien worlds and experiencing the cosmos firsthand is undeniably thrilling, it also raises important questions about responsibility and sustainability. How do we ensure that our presence in space doesn't harm the very environments we seek to explore? And how can we make these extraordinary experiences accessible to more than just a privileged few? One of the most pressing ethical concerns is the potential environmental impact on alien ecosystems. Imagine landing on a distant moon or exoplanet, only to discover that our presence has disrupted delicate ecosystems or introduced contaminants that could alter the planet's natural balance. Even unintentional actions like the release of Earth-based microbes or the disturbance of alien landscapes could have far-reaching consequences. To address this, we'd need strict protocols for planetary protection, ensuring that every mission prioritizes the preservation of these environments. This might include advanced sterilization techniques for spacecraft, restrictions on where tourists can go, and guidelines for interacting with alien life forms if they exist. Another critical issue is accessibility. In the early days of galactic tourism, the cost of space travel will likely be prohibitively high, making it a luxury available only to the wealthiest individuals. This raises questions about fairness and equity. Should the wonders of the universe be reserved for a select few, or should we strive to make them accessible to all? As technology advances and costs decrease, there's hope that space travel could become more democratized, but this will require intentional efforts to ensure that opportunities are distributed equitably. Governments, private companies, and international organizations could play a role in creating programs that allow people from diverse backgrounds to experience space, whether through subsidies, scholarships, or public-private partnerships. Beyond environmental and accessibility concerns, there's also the question of cultural and ethical responsibility. How do we approach the exploration of worlds that might already be inhabited, even if only by microbial life? What rights, if any, do these life forms have, and how do we respect them? These questions challenge us to think beyond our own interests and consider the broader implications of our actions. Establishing ethical frameworks for space exploration will be crucial, involving input from scientists, ethicists, and even representatives from Earth's diverse cultures to ensure that our approach is thoughtful and inclusive. As we navigate these ethical challenges, it's clear that galactic tourism isn't just about adventure, it's about stewardship. By addressing these concerns head-on, we can create a future where space travel is not only awe-inspiring but also responsible and inclusive. This vision requires collaboration, innovation, and a commitment to doing what's right, not just what's possible. And as we look to the stars, we're reminded that the universe is a shared heritage, one that we must protect and cherish for generations to come. With these ethical considerations in mind, let's turn our attention to another groundbreaking possibility: the discovery of extraterrestrial life and how it could reshape our understanding of the cosmos. Now, shifting our gaze to one of the most profound possibilities in galactic exploration, let's consider the discovery of extraterrestrial life. Imagine a moment when humanity finally encounters life beyond Earth, whether it's a microscopic organism on a distant moon or an intelligent civilization light years away. Such a discovery wouldn't just be a scientific breakthrough. It would fundamentally alter our understanding of biology, philosophy, and our place in the universe. The search for extraterrestrial life has long been a driving force behind space exploration. Scientists have focused on planets and moons within our solar system, like Mars or Europa, where conditions might support microbial life. Beyond our solar system, the discovery of exoplanets in the habitable zones of distant stars has fueled hope that life could exist elsewhere. But what would it mean if we found it? For biology, it would challenge our definitions of life itself. Are the building blocks of life universal, or could life arise from entirely different chemical processes? Discovering even the simplest forms of alien life could reveal new pathways for understanding how life begins and evolves. Beyond the scientific implications, the discovery of extraterrestrial life would have profound philosophical and cultural impact. It would force us to confront questions about our uniqueness and significance in the cosmos. Are we alone, or is life a common phenomenon across the universe? How would the knowledge of other life forms reshape our beliefs, religions, and worldviews? These questions would spark debates and discussions that could redefine humanity's collective identity. If we were to discover intelligent life, the implications would be even more transformative. Communication with an alien civilization could lead to an exchange of knowledge and ideas unlike anything we've ever experienced. Imagine learning about their history, technology, and culture, or even collaborating on scientific and philosophical challenges. However, it would also raise complex ethical and practical questions. How do we approach such a civilization? What responsibilities do we have in ensuring peaceful and respectful interactions? The discovery of intelligent life would require us to navigate uncharted territory, balancing curiosity with caution. As we ponder these possibilities, it's clear that the discovery of extraterrestrial life would be one of the most significant events in human history. It would not only expand our scientific horizons but also challenge us to rethink our place in the universe. And as we continue to explore the cosmos, we're reminded that the search for life is not just about finding answers, it's about asking the right questions and preparing ourselves for the profound changes that such a discovery would bring. With this in mind, let's now turn to the protocols and preparations humanity might need for first contact with extraterrestrial civilizations, and how we can approach this monumental moment with wisdom and foresight. Now, as we venture into the realm of first contact, let's explore the protocols and preparations humanity might need to navigate this unprecedented moment. The idea of encountering an extraterrestrial civilization is both thrilling and daunting, requiring careful planning and a unified global approach. How do we prepare for an event that could redefine our understanding of existence itself? First and foremost, communication would be the cornerstone of any first contact scenario. Establishing a means to exchange information with an alien civilization is no small feat. Scientists and linguists would need to develop universal methods of communication, potentially relying on mathematics, physics, or even visual symbols as a common language. The challenge lies in bridging the gap between vastly different forms of intelligence and expression. What if their way of thinking is entirely alien to ours? Preparing for such possibilities requires creativity, patience, and a willingness to learn. Diplomacy would also play a critical role in first contact. Unlike interactions between nations on Earth, engaging with an extraterrestrial civilization would involve navigating entirely unknown cultural, social, and ethical frameworks. Establishing trust and mutual respect would be essential to avoid misunderstandings or conflicts. This raises important questions. Who would represent humanity in such a moment? Would it be a single nation, a coalition of countries, or a global organization like the United Nations? Ensuring that humanity speaks with one voice would be crucial to presenting ourselves as a unified and peaceful species. Beyond communication and diplomacy, there are practical considerations to address. For instance, how do we protect both ourselves and the extraterrestrial civilization from potential biological risks? Introducing alien microbes to Earth, or vice versa, could have catastrophic consequences. Protocols for quarantine and containment would need to be developed to prevent unintended harm. Similarly, we must consider the ethical implications of our actions. How do we ensure that our curiosity doesn't lead to exploitation or harm? Respecting the autonomy and rights of any extraterrestrial beings we encounter would be a moral imperative. Another key aspect of preparation is public education and awareness. The discovery of intelligent alien life would undoubtedly spark widespread fascination, fear, and speculation. Governments and organizations would need to provide clear, accurate information to the public to prevent panic and misinformation. Engaging the global community in discussions about first contact could foster a sense of shared responsibility and excitement, helping humanity approach this moment with unity and purpose. As we contemplate these challenges, it's clear that first contact would be a defining moment for humanity. It would test our ability to collaborate, communicate, and coexist with beings whose existence we can scarcely imagine. By preparing thoughtfully and responsibly, we can ensure that this monumental event becomes an opportunity for growth, understanding, and connection rather than conflict or chaos. With these considerations in mind, let's now turn our attention to another groundbreaking possibility: space-based manufacturing and how zero-gravity environments could revolutionize the way we create and innovate. Now, shifting our gaze to the stars, let's explore how the unique conditions of space could transform the way we manufacture and innovate. Imagine a world where the limitations of Earth's gravity no longer constrain our creativity. In the weightlessness of space, entirely new possibilities emerge for manufacturing materials and products that are simply impossible to create on our home planet. One of the most exciting prospects of space-based manufacturing is the ability to produce ultra-pure materials. On Earth, gravity causes impurities to settle unevenly, making it difficult to create perfectly uniform substances. In zero gravity, however, materials can be mixed and solidified without these distortions, resulting in crystals, metals, and alloys of unparalleled quality. For example, semiconductors and fiber optics made in space could have fewer defects, leading to faster and more efficient electronics and communication systems. Another groundbreaking opportunity lies in the production of advanced biomaterials. In microgravity, scientists can grow human tissues and organs with greater precision, as cells can organize themselves more naturally without the interference of gravity. This could revolutionize medicine, enabling the creation of custom-made organs for transplants and accelerating research into treatments for diseases. Imagine a future where hospitals can order lab-grown organs manufactured in orbit, eliminating long waiting lists and saving countless lives. Space-based manufacturing also opens the door to creating entirely new materials. For instance, researchers are exploring the potential of producing super-strong, lightweight materials like metallic foams or carbon nanotubes in space. These materials could be used to build next-generation spacecraft, satellites, and even habitats on other planets, making space exploration more efficient and sustainable. The possibilities are as vast as the cosmos itself, but the benefits of space-based manufacturing aren't limited to advanced materials. The zero-gravity environment also allows for the development of unique products that simply can't be made on Earth. For example, perfectly spherical ball bearings, essential for precision machinery, are nearly impossible to produce on Earth due to gravitational distortions. In space, however, they can be manufactured with flawless symmetry, improving the performance of everything from industrial equipment to medical devices. As we look to the future, space-based manufacturing could become a cornerstone of our economy, creating new industries and transforming global trade. Factories in orbit could produce goods that are lighter, stronger, and more efficient, reducing the cost and environmental impact of transportation. This shift could also lead to the development of entirely new markets, as businesses and consumers gain access to products that were once unimaginable. With these incredible possibilities on the horizon, it's clear that space-based manufacturing has the potential to revolutionize not just how we create, but how we live. As we continue to push the boundaries of innovation, the stars may soon become our next industrial frontier. And with that, let's turn our attention to the economic implications of this transformative shift and how it could reshape our world. Now, as we venture further into the realm of space-based manufacturing, let's consider how this revolutionary shift could reshape the very foundations of our global economy. Picture a world where factories orbiting Earth become the new hubs of innovation, producing goods that are not only lighter and stronger but also more sustainable. This isn't just about creating new products, it's about redefining how we think about trade, industry, and economic growth. One of the most immediate impacts of space-based manufacturing would be the birth of entirely new industries. Imagine companies specializing in the production of ultra-pure materials, advanced biomaterials, or even space-grown food. These industries could create millions of jobs, from engineers and scientists to logistics experts and space station operators. The ripple effect would extend far beyond space as Earth-based businesses adapt to supply chains that now stretch into orbit. For instance, industries like healthcare, electronics, and construction could see dramatic improvements in the quality and availability of materials, driving innovation across the board. But the transformation doesn't stop there. Space-based manufacturing could also revolutionize global trade. With factories in orbit, the cost of transporting goods across vast distances could plummet. Instead of shipping heavy materials from one continent to another, we could manufacture them in space and deliver them directly to where they're needed. This would not only reduce the environmental impact of transportation, but also make goods more affordable and accessible worldwide. Imagine a future where a satellite built in orbit is delivered to a launch site in minutes, or where medical supplies are manufactured in space and sent directly to hospitals in remote areas. The economic benefits of this shift could be staggering. Space-based manufacturing could unlock trillions of dollars in new economic activity, creating a thriving space economy that rivals Earth's largest industries. Governments and private companies alike would invest heavily in space infrastructure, from manufacturing facilities to transportation networks. This influx of capital could accelerate technological advancements, making space exploration and habitation more feasible than ever before. However, this new frontier also raises important questions about equity and access. How do we ensure that the benefits of space-based manufacturing are shared fairly across nations and communities? Will this new economy widen the gap between wealthy and developing nations, or can it be a tool for global collaboration and progress? These are challenges we must address as we move forward, ensuring that the space economy becomes a force for good. As we look to the future, it's clear that space-based manufacturing has the potential to transform not just how we create, but how we connect and thrive as a global society. The stars may soon become our next economic frontier, offering opportunities as vast as the cosmos itself. And with that, let's turn our attention to the next visionary prediction: the rise of galactic governance and the need for a unified system of law to manage humanity's activities across the stars. As we step into the vast expanse of galactic governance, it's essential to consider how humanity might organize itself across the stars. With colonies and outposts potentially scattered across multiple star systems, the need for a unified system of governance and law becomes not just a possibility, but a necessity. Picture a future where humanity's reach extends far beyond Earth, with settlements on distant planets, moons, and even space stations. How do we ensure that these far-flung communities operate harmoniously, respecting shared principles while addressing the unique challenges of their environments? One of the first challenges will be establishing a framework for decision-making that spans light years. Unlike Earth, where communication is nearly instantaneous, the vast distances between star systems could create delays in dialogue and coordination. This raises questions about how to govern effectively when a message from one colony to another might take years to arrive. Would each star system operate as an independent entity, or would there be a central governing body overseeing all human activities in the galaxy? The answer likely lies somewhere in between, with a balance of local autonomy and overarching principles to guide humanity's collective progress. Another critical aspect of galactic governance is the development of laws that address the unique realities of space. For example, how do we regulate the use of resources on alien worlds? Should there be universal rights for all humans, regardless of where they live, or will laws need to adapt to the specific conditions of each colony? And what happens when conflicts arise between different star systems? These questions highlight the need for a legal system that is both flexible and robust, capable of addressing the complexities of life beyond Earth. Cooperation will be key to making galactic governance work. Just as nations on Earth have formed alliances and treaties, star systems may need to collaborate on issues like trade, defense, and scientific research. Imagine a galactic council where representatives from different colonies come together to discuss shared challenges and opportunities. Such a body could help prevent conflicts, foster innovation, and ensure that the benefits of space exploration are shared equitably. Yet, even with the best intentions, conflicts are inevitable. Disputes over territory, resources, or cultural differences could test the resilience of any galactic governance system. How do we resolve these conflicts without resorting to violence? The development of interstellar diplomacy and conflict resolution mechanisms will be crucial, ensuring that humanity's expansion into the galaxy is marked by cooperation rather than division. As we look ahead, the rise of galactic governance represents both a challenge and an opportunity. It's a chance to rethink how we organize ourselves as a species, creating systems that reflect our highest ideals while addressing the realities of life in the cosmos. The stars may be vast, but our ability to work together will determine whether we thrive among them. And with that, let's turn our gaze to the next frontier, the role of Earth in a galactic civilization and how our home planet might remain a central hub in an interstellar society. As we shift our focus to the role of Earth in a galactic civilization, it's worth considering how our home planet might evolve into a central hub for humanity's interstellar endeavors. Earth, with its rich history and established infrastructure, could serve as the political, cultural, and economic heart of a sprawling galactic society. But maintaining this role won't be without its challenges, especially as humanity spreads across the stars. One of Earth's most significant advantages is its deep-rooted connection to human identity. For centuries, Earth has been the cradle of civilization, the birthplace of art, science, and culture. This legacy could make it a natural focal point for governance, diplomacy, and decision-making in a galactic context. Imagine Earth as the headquarters of a galactic council, where representatives from distant colonies gather to discuss policies, resolve disputes, and coordinate large-scale initiatives. Its central location relative to the rest of the galaxy could also make it a logistical hub for trade and communication, even as other star systems develop their own unique identities. However, as colonies grow and thrive on distant worlds, Earth's dominance may face challenges. Colonies with abundant resources or advanced technologies might begin to question why Earth should retain its central role. After all, why should decisions made on Earth dictate the lives of those living light years away? This tension could lead to debates about power distribution, with some colonies advocating for greater autonomy or even independence. Balancing Earth's leadership with the aspirations of distant colonies will be a delicate task, requiring diplomacy and compromise. Another challenge lies in maintaining unity across vast distances. Even with advanced communication technologies, the sheer scale of the galaxy could create a sense of disconnection between Earth and its far-flung colonies. How do we ensure that Earth remains relevant to those living on the frontier of human expansion? One solution might be to foster a shared sense of identity and purpose, emphasizing the common goals that unite humanity across the stars. Earth could also invest in cultural exchange programs, educational initiatives, and collaborative projects that strengthen ties between colonies and their home planet. Yet, Earth's role in galactic politics isn't just about governance and unity, it's also about responsibility. As the birthplace of humanity, Earth has a unique obligation to lead by example, promoting sustainability, equity, and ethical progress. This means addressing issues like climate change, resource management, and social inequality, not just for the sake of Earth's inhabitants but as a model for colonies to follow. A thriving, equitable Earth could inspire trust and cooperation across the galaxy, while a struggling one might sow discord and division. Ultimately, Earth's place in a galactic civilization will depend on its ability to adapt and evolve. It must balance its historical significance with the need to empower and respect its colonies, fostering a sense of shared destiny rather than dominance. The stars may beckon us to explore new frontiers, but Earth's role as a guiding light will remain crucial, ensuring that humanity's journey into the cosmos is one of unity, progress, and hope. And with that, let's turn our attention to the next visionary prediction, the tantalizing possibilities of time travel and temporal exploration. Now, let's venture into one of the most mind-bending frontiers of galactic exploration, the concept of time travel and temporal exploration. As humanity stretches its reach across the stars, the very nature of time itself could become a new frontier to conquer. Imagine a future where the vast distances of space aren't the only barriers we overcome, where the flow of time becomes a tool, a challenge, and perhaps even a playground for discovery. At the heart of this idea lies the intriguing intersection of advanced physics and galactic exploration. Theories like Einstein's relativity have already shown us that time isn't as fixed as it seems. Near massive objects or at near light speeds, time can slow down or speed up, a phenomenon known as time dilation. But what if we could harness these principles to move not just through space, but through time itself? Picture a spacecraft equipped with technology that manipulates space-time, allowing it to travel to distant eras, whether to witness the birth of a star, revisit pivotal moments in human history, or explore civilizations that once thrived in the galaxy. The scientific possibilities are as thrilling as they are complex. For instance, wormholes, hypothetical tunnels through space-time, could serve as shortcuts not just across the galaxy, but across time. If we could stabilize and traverse these cosmic gateways, the universe's past, present, and future might all become accessible. Similarly, the concept of closed time-like curves, where the fabric of space-time loops back on itself, suggests that time travel might not be as far-fetched as it sounds. These ideas, while still theoretical, could redefine our understanding of reality and our place within it. But with such power comes profound ethical dilemmas. If time travel were possible, how would we use it responsibly? Would we intervene in historical events, potentially altering the course of history? What if our actions in the past created unintended consequences, rippling through time and reshaping the future? And then there's the question of access. Who gets to control this technology? Would it be a tool for scientific discovery, or could it become a weapon in the wrong hands? These questions highlight the delicate balance between exploration and responsibility, a theme that echoes throughout humanity's journey into the cosmos. Beyond the ethical challenges, there's also the sheer wonder of what time travel could reveal. Imagine standing on a planet billions of years in the past, witnessing the formation of its first oceans. Or visiting a future Earth transformed by centuries of technological and societal evolution. Time travel could unlock secrets of the universe that are currently beyond our reach, offering insights into the origins of life, the fate of stars, and the ultimate destiny of the cosmos. Yet, as we dream of these possibilities, we must also confront the limitations of our current understanding. Time travel remains a realm of speculation, a tantalizing idea that pushes the boundaries of science and imagination. But as history has shown, what seems impossible today may become reality tomorrow. The pursuit of time travel, much like galactic exploration itself, is a testament to humanity's unyielding curiosity and our desire to push beyond the known. As we ponder the mysteries of time and space, let's turn our attention to the next visionary prediction, the paradoxes and consequences of time travel and how they might shape our understanding of the universe. Now, as we delve deeper into the mysteries of time travel, we encounter one of its most fascinating and perplexing aspects, the paradoxes it creates. These paradoxes aren't just theoretical puzzles. They're profound challenges that could reshape our understanding of cause and effect, reality, and even free will. Let's start with the most famous of these, the grandfather paradox. Imagine traveling back in time and accidentally preventing your own birth. If you were never born, how could you have traveled back in time in the first place? This paradox highlights the tangled web of consequences that time travel could weave, raising questions about the stability of history and the nature of existence itself. Another intriguing paradox is the bootstrap paradox, where an object or piece of information is caught in an endless loop with no clear origin. Picture a scientist who travels back in time and gives a younger version of themselves the blueprint for a revolutionary invention. The younger scientist then grows up to build the invention and later travels back to deliver the same blueprint. But where did the blueprint originally come from? This paradox challenges our understanding of creation and causality, suggesting that some things might exist outside the bounds of linear time. Then there's the butterfly effect, a concept popularized by chaos theory. Even the smallest actions in the past could have monumental consequences in the future. A single misplaced word, a changed decision, or an altered event could ripple through time, creating a vastly different present or future. This idea underscores the immense responsibility that would come with time travel. Every action, no matter how minor, could have unpredictable and far-reaching effects, making the ethical dilemmas we discussed earlier even more complex. But what if time travel doesn't just alter history? What if it creates entirely new timelines? This is the idea behind the multiverse theory, where every decision or change spawns a parallel universe. In this scenario, traveling back in time and altering an event wouldn't erase the original timeline, it would simply create a new one, branching off from the point of change. This raises fascinating questions about identity and continuity. Would you still be you in a different timeline? And if infinite timelines exist, how do we define what's real or meaningful? These paradoxes and possibilities aren't just thought experiments. They have real implications for how we approach time travel, both scientifically and ethically. They remind us that time, far from being a straightforward progression, is a complex and dynamic dimension, full of mysteries we've only begun to unravel. As we continue to explore the frontiers of galactic exploration, the study of time travel could unlock not just new technologies, but new ways of understanding our place in the universe. With these paradoxes in mind, let's turn our attention to the next visionary prediction: galactic-scale environmentalism, and how humanity might adopt a cosmic perspective on preserving the wonders of the universe. As we shift our gaze from the mind-bending paradoxes of time travel, let's consider a future where humanity's environmental consciousness expands beyond Earth to encompass the entire galaxy. Galactic-scale environmentalism isn't just about preserving our home planet, it's about recognizing the interconnectedness of all celestial bodies and the responsibility we have to protect the delicate balance of life wherever it may exist. Imagine a future where humanity, now a spacefaring civilization, takes stewardship of entire star systems, ensuring that our exploration and colonization efforts don't come at the cost of alien ecosystems or cosmic wonders. One of the key principles of galactic environmentalism would be the concept of sustainable resource use. Just as we've learned the hard way on Earth, exploiting resources without regard for the consequences can lead to irreversible damage. In a galactic context, this means developing technologies and practices that allow us to harvest materials from asteroids, moons, and planets without disrupting their natural states. For example, mining operations on barren worlds could be designed to leave minimal environmental footprints, while advanced recycling systems could ensure that waste is repurposed rather than discarded into space. But sustainability isn't just about resource management, it's also about preserving the beauty and diversity of the universe. Picture a future where humanity establishes protected zones around planets with unique geological features or potential for life. These cosmic nature reserves would be off-limits to industrial activity, allowing alien ecosystems to thrive undisturbed. Such efforts would require international, or rather interstellar cooperation, with agreements and treaties ensuring that no single entity can exploit these pristine environments for profit. Another critical aspect of galactic environmentalism is the ethical consideration of terraforming. While transforming barren worlds into habitable ones might seem like a noble goal, it raises important questions about the rights of any existing life forms, no matter how primitive. Should we alter an entire planet's ecosystem to suit our needs, or should we adapt ourselves to its natural conditions? These decisions would require careful thought and a deep respect for the intrinsic value of all forms of life, even those vastly different from our own. Of course, adopting a galactic perspective on environmentalism also means addressing the challenges of space debris and pollution. As humanity expands into the stars, the risk of cluttering space with defunct satellites, discarded equipment, and other debris grows exponentially. Developing systems to clean up orbital pathways and prevent further contamination would be essential to maintaining the health of our galactic neighborhood. This could involve everything from advanced recycling stations to autonomous drones designed to collect and repurpose space junk. Ultimately, galactic-scale environmentalism is about more than just protecting the universe. It's about redefining our relationship with it. It's a call to see ourselves not as conquerors of the cosmos, but as caretakers of its infinite wonders. By embracing this mindset, we can ensure that our journey into the stars is one of harmony, respect, and coexistence, rather than exploitation and destruction. As we continue to explore the vastness of space, let's remember that the galaxy is not just a resource to be used, it's a home to be cherished. With this vision of cosmic stewardship in mind, let's turn our attention to the next frontier, the delicate balance between technological progress and the preservation of alien ecosystems, and how humanity might navigate this complex challenge. Balancing technological progress with the preservation of alien ecosystems is one of the most pressing challenges humanity will face as we expand into the galaxy. On one hand, our survival and growth as a spacefaring civilization depend on harnessing the resources and opportunities that the cosmos offers. On the other, we must ensure that our actions don't irreparably harm the very environments we seek to explore and understand. Striking this balance will require a combination of innovation, restraint, and a deep respect for the unknown. One of the first steps in achieving this balance is developing technologies that minimize environmental impact. For instance, instead of strip mining entire planets, we could focus on extracting resources from asteroids or moons with no existing ecosystems. These celestial bodies, often barren and lifeless, could provide the raw materials we need without threatening delicate alien environments. Additionally, advancements in synthetic biology and nanotechnology might allow us to create materials in space, reducing the need for resource extraction altogether. However, technology alone won't solve the problem. We'll also need to establish strict ethical guidelines and regulatory frameworks to govern our activities in space. Imagine a future where every mission to a new planet or star system is accompanied by a team of environmental scientists tasked with assessing the potential impact of human activity. These experts would determine whether a world is suitable for colonization, mining, or even scientific study, ensuring that our presence doesn't disrupt any existing ecosystems. Such measures would require unprecedented levels of international cooperation, as well as a shared commitment to prioritizing preservation over profit. Another key consideration is the concept of adaptive coexistence. Rather than imposing our way of life on alien worlds, we might need to adapt to their unique conditions. For example, instead of terraforming a planet to make it more Earth-like, we could develop habitats that work in harmony with its natural environment. This approach would not only protect alien ecosystems, but also challenge us to think creatively about how we live and thrive in space. It's a reminder that progress doesn't always mean domination. Sometimes it means finding ways to coexist with the unknown. Of course, balancing progress and preservation won't be easy. There will always be competing interests, from corporations seeking profit to governments pursuing strategic advantages. The temptation to exploit new worlds for short-term gain could be overwhelming, especially in the early stages of galactic exploration. That's why it's crucial to establish a strong cultural and philosophical foundation for our actions in space. By fostering a sense of cosmic stewardship, we can ensure that future generations view the galaxy not as a resource to be plundered, but as a shared heritage to be protected. Ultimately, the challenge of balancing progress and preservation is a test of our values as a species. It asks us to consider what kind of civilization we want to become, one that prioritizes growth at any cost, or one that values harmony and respect for all forms of life. As we venture further into the cosmos, let's strive to make choices that reflect the best of humanity, ensuring that our journey into the stars is one of discovery, not destruction. With this delicate balance in mind, let's now explore how humanity might uncover the secrets of ancient alien civilizations and the ethical dilemmas that come with studying their remains. As we turn our attention to the mysteries of the past, let's envision a future where space archaeologists become the historians of the cosmos. Picture this: teams of researchers, equipped with advanced tools and technologies, venturing to distant planets and moons to uncover the remnants of civilizations that once flourished among the stars. These ancient alien ruins could hold the key to understanding not only the history of the galaxy, but also our place within it. The field of space archaeology would likely begin with the discovery of structures or artifacts that defy natural explanations. Imagine stumbling upon the remains of a massive, intricately designed city on a planet long thought to be uninhabitable, or perhaps finding a network of tunnels beneath the surface of a moon, hinting at a civilization that thrived in the shadows. These discoveries would challenge our understanding of life, intelligence, and the conditions necessary for civilizations to arise. One of the most exciting aspects of space archaeology is the potential to piece together the stories of these lost civilizations. By analyzing their architecture, technology, and even their art, we could gain insights into their culture, values, and way of life. For instance, a series of carvings or inscriptions might reveal how they viewed the universe, their gods, or their own mortality. Such findings could offer profound lessons for humanity, reminding us of the fragility and resilience of civilizations across time and space. However, the study of ancient alien ruins would also raise significant ethical questions. How should we approach these sites? Should we excavate and preserve them, or leave them untouched as a testament to their creators? The act of disturbing these ruins could be seen as a form of cultural appropriation, especially if we lack a full understanding of their significance. Moreover, there's the risk of inadvertently damaging or destroying irreplaceable artifacts in our quest for knowledge. To navigate these challenges, space archaeologists would need to adopt a code of ethics that prioritizes respect and preservation. This might involve using non-invasive techniques such as remote sensing and 3D imaging to study ruins without physically altering them. It could also mean collaborating with experts in fields like anthropology and ethics to ensure that our actions align with a broader commitment to cultural sensitivity and stewardship. The implications of space archaeology extend far beyond the scientific community. Discovering evidence of ancient alien civilizations could reshape our understanding of history, philosophy, and even religion. It might force us to confront questions about the nature of intelligence, the rise and fall of civilizations, and the possibility of life beyond Earth. These discoveries could inspire a new era of exploration, driven not just by the desire for resources or territory, but by a profound curiosity about the stories hidden among the stars. As we continue to explore the galaxy, let's remember that our journey is not just about the future, it's also about uncovering the past. By studying the remnants of ancient civilizations, we can learn from their triumphs and mistakes, gaining wisdom that might guide us as we build our own galactic legacy. And with that, let's now consider the ethical considerations of space archaeology and how we might approach these discoveries with the respect they deserve. Now, as we delve deeper into the fascinating world of space archaeology, it's essential to pause and reflect on the ethical dimensions of this groundbreaking field. The study of ancient alien artifacts and ruins isn't just a scientific endeavor, it's a moral responsibility. How we choose to interact with these remnants of civilizations long gone could define our legacy as explorers and stewards of the galaxy. One of the most pressing ethical questions is whether we should even disturb these sites in the first place. Imagine uncovering a structure that has stood untouched for millions of years, a silent witness to the rise and fall of an entire civilization. By excavating or altering it, are we preserving history or are we erasing it? Some argue that these sites should remain as they are, serving as cosmic monuments to the civilizations that created them. Others believe that careful study is necessary to unlock the secrets they hold, even if it means some level of intervention. Another critical consideration is the potential for cultural appropriation. If we discover artifacts or structures that hold deep cultural or spiritual significance to an alien civilization, do we have the right to claim them as objects of study? This becomes even more complex if we encounter evidence of a civilization that still exists in some form. How do we balance our curiosity and scientific progress with respect for their heritage and autonomy? These questions challenge us to think beyond our human-centric perspective and consider the broader implications of our actions. There's also the risk of unintended consequences. Disturbing ancient sites could lead to the destruction of irreplaceable artifacts or even trigger unforeseen environmental or structural changes. For example, removing a single artifact from its original context might disrupt the delicate balance of a site, making it impossible to fully understand its purpose or significance. To mitigate these risks, space archaeologists would need to adopt non-invasive techniques such as advanced imaging and remote sensing to study sites without physically altering them. Collaboration will be key in navigating these ethical challenges. Space archaeologists would need to work closely with ethicists, anthropologists, and even representatives of any living alien civilizations to develop guidelines that prioritize respect, preservation, and cultural sensitivity. These guidelines could include protocols for documenting and preserving sites, as well as frameworks for sharing knowledge and artifacts with the broader scientific community and the public. Ultimately, the ethics of space archaeology remind us that exploration is not just about discovery, it's about responsibility. As we uncover the stories of civilizations that came before us, we must ask ourselves what kind of explorers we want to be. Will we be remembered as those who plundered the past for our own gain, or as those who approached these discoveries with humility, respect, and a commitment to preserving the legacy of the cosmos? The choices we make today will shape not only our understanding of the galaxy, but also our place within it. With these ethical considerations in mind, let's now turn our attention to how education might evolve in a galactic civilization, where knowledge and culture are shared across species and star systems. As we shift our focus from the ethical dilemmas of space archaeology to the broader implications of galactic exploration, let's consider how education might transform in a civilization that spans multiple star systems. In a galaxy teeming with diverse cultures, species, and histories, the way we learn and share knowledge could undergo a radical evolution, becoming a cornerstone of unity and progress. Imagine a future where education is no longer confined to the boundaries of a single planet or species. Instead, it becomes a universal endeavor, accessible to all beings across the galaxy. This galactic-scale education system would prioritize inclusivity, ensuring that knowledge is shared freely and equitably, regardless of one's origin or background. Think of it as a cosmic library where the collective wisdom of countless civilizations is available at the touch of a button, fostering a deeper understanding of the universe and our place within it. One of the most exciting possibilities is the rise of cross-cultural learning. In a galactic civilization, students wouldn't just study their own history or science, they'd explore the art, philosophy, and technology of alien cultures. Picture a classroom where humans learn about the mathematical systems of a species from a distant star, or where an alien student studies Earth's Renaissance art. This exchange of ideas wouldn't just enrich individual minds, it could spark innovations and breakthroughs that benefit the entire galaxy. Technology would play a pivotal role in making this vision a reality. Advanced communication networks powered by quantum entanglement or other futuristic technologies could enable real-time collaboration between educators and learners across vast distances. Virtual reality classrooms might allow students to immerse themselves in alien environments, experiencing other worlds and cultures firsthand. Artificial intelligence could personalize learning experiences, adapting to each student's unique needs and helping them grasp complex concepts with ease. But galactic education wouldn't just be about acquiring knowledge, it would also be about fostering empathy and understanding. In a universe filled with diverse life forms, learning to appreciate and respect differences would be essential. Educational programs might include modules on interspecies communication, cultural sensitivity, and conflict resolution, preparing students to navigate the complexities of a multicultural galaxy. This emphasis on empathy could help bridge divides and build a more harmonious interstellar society. Of course, challenges would arise: language barriers, differing cognitive processes, and even conflicting educational philosophies could complicate the sharing of knowledge. To address these issues, educators would need to develop universal frameworks that accommodate the unique needs of each species while maintaining a cohesive curriculum. Collaboration between civilizations would be key, ensuring that no one is left behind in this grand educational endeavor. As we look to the future, it's clear that galactic-scale education has the potential to transform not just how we learn, but how we connect with one another. By embracing the diversity of the cosmos and committing to the free exchange of knowledge, we could create a civilization that thrives on curiosity, collaboration, and mutual respect. And as we prepare to explore the role of artificial intelligence in shaping this educational future, let's remember that the pursuit of knowledge is not just a human endeavor, it's a universal one, binding us all together in the quest to understand the mysteries of the galaxy. Now, let's take a closer look at how artificial intelligence could revolutionize education on a galactic scale. In a universe teeming with diverse species and cultures, the role of artificial intelligence would be nothing short of transformative. Imagine a system where learning is tailored to the unique needs of every individual, whether they're a human from Earth, a silicon-based life form from a distant star, or a sentient gas cloud from the outer reaches of the galaxy. Artificial intelligence could analyze the cognitive processes, learning styles, and cultural backgrounds of each student, creating personalized curricula that adapt in real time to their progress and challenges. One of the most exciting possibilities is the ability of artificial intelligence to bridge the gap between vastly different species. For instance, an AI system could translate complex alien concepts into terms that humans can understand, or vice versa. Picture a scenario where a human student is learning about the advanced physics of a civilization that perceives time in multiple dimensions. Artificial intelligence could break down these ideas into digestible lessons, using analogies and visualizations that resonate with the student's own experiences. Similarly, an alien student studying human history could receive lessons that contextualize Earth's events within their own cultural framework, fostering a deeper connection and understanding. Artificial intelligence could also play a crucial role in fostering collaboration across species. Virtual classrooms powered by AI could bring together students from different corners of the galaxy, enabling them to work on projects, solve problems, and exchange ideas in real time. These AI-driven platforms could automatically adjust for language barriers, cognitive differences, and even time zones, ensuring that every participant feels included and valued. This kind of collaborative learning wouldn't just enhance individual education, it could spark innovations that benefit entire civilizations. Moreover, artificial intelligence could help preserve and share the knowledge of extinct or endangered species. Imagine an AI system that compiles the wisdom of a long-lost civilization, translating their philosophies, technologies, and art into formats that can be studied and appreciated by future generations. This would not only enrich the galactic educational landscape, but also ensure that no culture's contributions are forgotten. In this way, artificial intelligence could act as a guardian of knowledge, preserving the diversity of the cosmos for all to learn from. Of course, integrating artificial intelligence into galactic education would come with its own set of challenges. Ethical considerations, such as ensuring that AI systems remain unbiased and respect the autonomy of all species, would need to be addressed. There's also the question of how to balance the role of artificial intelligence with the human or alien touch that makes education meaningful. After all, learning isn't just about acquiring information. It's about forming connections, asking questions, and exploring the unknown. Artificial intelligence would need to enhance these experiences, not replace them. As we envision this future, it's clear that artificial intelligence has the potential to create a truly universal education system, one that transcends species, cultures, and even time. By personalizing learning, fostering collaboration, and preserving knowledge, artificial intelligence could help build a galaxy where understanding and empathy are the foundations of progress. And as we prepare to explore the next frontier of galactic-scale exploration, let's remember that the tools we create, like artificial intelligence, are not just instruments of discovery, they're bridges that connect us all in the shared pursuit of knowledge. Now, shifting our gaze to the realm of health and longevity, let's explore how space-based medicine could redefine the way we approach healthcare. In the unique environment of space, where gravity is absent and cosmic radiation is a constant presence, scientists are uncovering groundbreaking insights that could revolutionize medicine on Earth and beyond. The challenges of space travel have pushed researchers to develop innovative solutions, many of which hold the potential to extend human life and combat diseases in ways we've never imagined. One of the most promising areas of space-based healthcare is the study of aging. In microgravity, the human body undergoes rapid changes: muscle atrophy, bone density loss, and even alterations at the cellular level. While these effects might seem detrimental, they provide a unique opportunity to study the mechanisms of aging in an accelerated environment. By understanding how cells and tissues degrade in space, scientists can identify new pathways to slow or even reverse the aging process. Imagine a future where treatments developed in space could help humans live longer, healthier lives, free from the ailments that currently accompany old age. Another exciting frontier is the development of advanced medical technologies tailored for space. For instance, 3D bioprinting in zero gravity allows for the creation of complex tissues and organs with unprecedented precision. This technology could lead to breakthroughs in regenerative medicine, enabling the repair or replacement of damaged organs without the need for invasive surgeries. Picture a scenario where astronauts on long-term missions can print replacement tissues on demand, or where patients on Earth receive custom-grown organs that perfectly match their biological needs. The possibilities are as vast as the cosmos itself, Space-based research is also shedding light on the effects of cosmic radiation, which poses a significant risk to astronauts but also offers a unique opportunity to study its impact on human health. By understanding how radiation damages DNA and triggers diseases like cancer, scientists can develop more effective treatments and preventive measures. These discoveries could lead to new therapies that protect not only astronauts but also people on Earth who are exposed to high levels of radiation, such as cancer patients undergoing radiation therapy. Moreover, the isolation and confined environments of space missions have prompted advancements in mental health care. Astronauts face immense psychological challenges, from the stress of isolation to the pressure of high-stakes missions. The solutions developed to support their mental well-being, such as virtual reality therapy, AI-driven counseling, and advanced monitoring systems, could be adapted to help people on Earth dealing with similar issues. These innovations could transform how we approach mental health, making care more accessible and effective for everyone. Of course, the journey to integrating space-based healthcare into everyday life isn't without its challenges. Ethical considerations, such as ensuring equitable access to these advanced treatments, will need to be addressed. There's also the question of how to balance the pursuit of longevity with the natural cycles of life. As we push the boundaries of what's possible, we must also reflect on the values that guide our progress. As we look to the stars, it's clear that space-based healthcare holds the potential to transform not just how we heal, but how we live. From slowing the aging process to curing diseases and enhancing mental well-being, the innovations born in the cosmos could bring us closer to a future where humanity thrives, both on Earth and among the stars. And as we continue to explore the vast unknown, let's remember that the pursuit of health and longevity is not just about extending life, it's about enriching it. Now, as we delve deeper into the realm of space-based healthcare, it's essential to pause and consider the ethical dimensions that come with these groundbreaking advancements. The ability to extend human life and cure diseases through innovations born in space raises profound questions about fairness, accessibility, and the very nature of what it means to live a fulfilling life. One of the most pressing ethical concerns is the issue of equitable access. If treatments developed in space, such as anti-aging therapies or advanced regenerative medicine, become available, who will have the privilege of accessing them? Will these life-changing technologies be reserved for the wealthy or those living in developed nations, or can they be made accessible to all, regardless of socioeconomic status? In a galactic society where humanity may be spread across multiple star systems, ensuring fair distribution of healthcare resources will be a monumental challenge. The risk of creating a divide between those who can afford these treatments and those who cannot could lead to new forms of inequality, both on Earth and beyond. Another ethical dilemma revolves around the concept of longevity itself. While extending human life is an exciting prospect, it also forces us to confront questions about the natural cycle of life and death. Is it ethical to pursue immortality or near immortality if it disrupts the balance of ecosystems, economies, and social structures? For instance, if people live significantly longer, how will societies manage population growth, resource allocation, and intergenerational dynamics? These are not just scientific or logistical challenges, they are deeply philosophical questions that require careful consideration. Additionally, the psychological and societal impacts of extended lifespans must be addressed. Living longer doesn't necessarily mean living better. Without meaningful purpose, relationships, and opportunities for growth, extended life could lead to increased rates of boredom, depression, or existential crises. How do we ensure that longer lives are also richer, more fulfilling lives? This challenge extends beyond medicine and into the realms of education, culture, and community building. The ethical implications of space healthcare also touch on the potential for unintended consequences. For example, if we develop technologies to protect astronauts from cosmic radiation, could these same technologies be weaponized or misused? The dual-use nature of many medical advancements means that we must carefully weigh the benefits against the risks, ensuring that these innovations are used responsibly and for the greater good. Finally, as we expand into the galaxy, we must consider how our healthcare systems will adapt to the diverse needs of a multi-planetary civilization. Will the same treatments work for humans living on Mars, Europa, or distant exoplanets? How do we account for the unique environmental and physiological challenges faced by different populations? Creating a healthcare system that is both universal and adaptable will require unprecedented levels of collaboration and foresight. As we stand on the brink of a new era in healthcare, it's clear that the ethical questions surrounding space-based medicine are as vast and complex as the cosmos itself. Balancing progress with responsibility, accessibility with innovation, and longevity with meaning will be critical as we navigate this uncharted territory. The decisions we make today will shape not only the future of healthcare but also the future of humanity itself. And as we continue to explore the stars, let's ensure that our pursuit of health and longevity is guided by compassion, equity, and a deep respect for the value of every life. Now, as we venture into the realm of the unknown, let's turn our gaze toward one of the most mind-bending possibilities in galactic exploration, the search for parallel universes. Imagine a reality where our universe is just one of countless others, each with its own unique laws of physics, histories, and perhaps even versions of ourselves. This isn't just science fiction, it's a concept rooted in cutting-edge scientific theories, and galactic exploration could bring us closer to uncovering the truth. The idea of parallel universes stems from theories like the multiverse hypothesis, which suggests that our universe is part of a vast, interconnected web of universes. Some of these universes might be nearly identical to ours, with only minor differences, while others could be wildly different, governed by entirely unfamiliar physical laws. Galactic exploration could provide the tools and opportunities to test these theories, potentially revealing evidence of other universes through anomalies in cosmic radiation, gravitational waves, or even the behavior of dark matter. But what would discovering parallel universes mean for science and philosophy? For scientists, it would revolutionize our understanding of reality itself. It could answer questions about the origins of our universe, the nature of dark energy, and why the fundamental constants of physics seem so finely tuned for life. It might even provide insights into the ultimate fate of the cosmos. For philosophers, the implications are equally profound. The existence of parallel universes challenges our notions of identity, free will, and the uniqueness of human existence. Are there infinite versions of us making different choices in other universes? And if so, what does that mean for our sense of self and purpose? The search for parallel universes also raises practical questions about how we might interact with them, if at all. Could we ever communicate with or travel to another universe? While this remains speculative, some theories suggest that wormholes or quantum entanglement might offer pathways between universes. However, the challenges are immense, from the energy requirements to the potential dangers of destabilizing the fabric of reality itself. As we push the boundaries of galactic exploration, the search for parallel universes represents the ultimate frontier, a quest to understand not just our place in the cosmos, but the very nature of existence. It's a journey that blends science, philosophy, and imagination, inviting us to rethink everything we thought we knew about reality. And while the answers may still lie beyond our reach, the pursuit itself is a testament to humanity's boundless curiosity and determination to explore the unknown. Now, as we delve deeper into the mysteries of parallel universes, it's important to consider the immense challenges that come with exploring the multiverse. While the idea of discovering other realities is thrilling, the scientific and technological hurdles we face are equally daunting. one of the biggest challenges lies in detecting evidence of parallel universes in the first place. Current theories suggest that signs of other universes might be hidden in cosmic microwave background radiation or gravitational waves. However, these signals, if they exist, would be incredibly faint and difficult to distinguish from the noise of our own universe. Developing the technology to detect such subtle anomalies would require breakthroughs in observational instruments, far beyond what we have today. Another major obstacle is the energy required to even attempt interactions with other universes. Theoretical models suggest that creating a stable wormhole or harnessing quantum entanglement to bridge universes would demand energy levels that are currently unimaginable. For context, the energy needed might exceed the total output of entire stars, making such endeavors impractical with our current understanding of physics and engineering. Beyond the technical challenges, there are also significant risks involved in multiverse exploration. Manipulating the fabric of reality to interact with other universes could have unintended consequences. For instance, creating a wormhole or attempting to breach the boundaries between universes might destabilize spacetime itself, potentially leading to catastrophic outcomes. The very act of observing or interacting with another universe could alter its state, raising ethical questions about our responsibility as explorers. Moreover, the philosophical implications of multiverse exploration add another layer of complexity. If we were to discover that other universes exist, how would we reconcile their existence with our own? Would we prioritize communication, or would the risks of interference outweigh the potential benefits? These questions highlight the delicate balance between scientific curiosity and ethical responsibility. Despite these challenges, the pursuit of multiverse exploration remains a cornerstone of humanity's quest to understand the cosmos. It pushes the boundaries of our knowledge, inspiring us to develop new technologies and rethink our place in the grand tapestry of existence. While the answers may still be out of reach, the journey itself is a testament to our unyielding desire to explore the unknown. As we continue to push the limits of galactic exploration, the search for parallel universes reminds us that the greatest discoveries often come with the greatest challenges. And it's through overcoming these obstacles that we inch closer to unlocking the secrets of the multiverse. As we bring this journey through 30 visionary predictions to a close, it's clear that the future of galactic exploration holds limitless possibilities. From interstellar travel and self-sustaining colonies to the discovery of extraterrestrial life and the tantalizing mysteries of parallel universes, humanity stands on the brink of a new era. These predictions aren't just dreams, they're blueprints for a future where we transcend the boundaries of our planet and become a truly galactic civilization. Each of these ideas challenges us to think bigger, innovate faster, and collaborate more deeply. They remind us that the universe is vast, filled with wonders waiting to be uncovered, and that our role as explorers is far from over. Whether it's harnessing space-based energy, building a galactic internet, or navigating the ethical complexities of first contact, every step forward brings us closer to understanding our place in the cosmos. But this future isn't just about technology or discovery, it's about us. It's about our curiosity, our resilience, and our ability to dream beyond the stars. The challenges are immense, but so are the rewards. By pushing the boundaries of what's possible, we're not just shaping the future of space exploration, we're shaping the future of humanity itself. So, what can you do to be part of this incredible journey? Start by dreaming big. Share your ideas, support scientific research, and advocate for the advancements that will take us to the stars. Whether you're a scientist, an engineer, a student, or simply someone who looks up at the night sky in awe, you have a role to play in this grand adventure. If this vision of the future excites you, don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss an update on the latest breakthroughs in space exploration. Together, let's turn these visionary predictions into reality. The universe is waiting, let's go explore it.